Hello, my name's Daisy Abbott, and this is a presentation of our paper on the design of provoking games to encourage critical reflection. The SECRIOUS project takes a game-based approach to improving knowledge and attitudes in cybersecurity practices. Our methodology includes interdisciplinary serious game co-design with coders and aims to produce critical reflection on participants' own coding practice. The SECRIOUS project started with three overarching topics which are core to cybersecurity. These are code security, API security, and the security lifecycle. Then early in co-design work with our community and our stakeholders, we developed 5 overlapping themes relevant to cybersecurity, and these are coder practices, code motivation, morality, resources, and communication. Our overall goal is to co-create serious games for cybersecurity with participants at a game jam, with hopefully then impacting on increasing cybersecurity awareness and practice going forwards. However, that's not what this paper is about. This paper is about a part of that process, the design of provoking games to facilitate reflection in game jam participants to attempt to improve the quality of the game jam method. So we're just looking here at the first column, which drew on the themes defined by our early participants to create provoking games, which then themselves feed into the rest of the project's activities. We define a provoking game as one that uses the techniques of reflective game design to produce cognitive and affective challenge, a sort of eudaimonic as opposed to hedonic appreciation of the player experience. That means a sense of contentment and understanding of your place in the world as opposed to hedonic pleasure. This emphasizes a player's sense of purpose and aims to create change in attitudes and or practice outside of the game context. So based on a synthesis of the literature, we define reflection as a conscious exploration of the self to construct new insights. And in the paper, we look at the 3 main stages that lead to reflection, which are breakdown, also called discomfort, surprise, conflict, or dissonance in the literature, inquiry, which is analysis, and then possibly, optionally, transformation, which is the result of a new perspective and an affective or cognitive change. And hopefully you'll see how we incorporated these 3 key stages into our game design. So provoking a lasting change in attitudes towards secure coding practice requires dialogic or inquiry-based reflection. So our goal was to create games that targeted these 3 higher levels of reflection identified in the framework from the literature. The good news is that games and play are already well suited for creating both reflection in action and reflection on action. Khaled notes that non-trivial challenge, analysis and problem solving, key parts of the reflective process, are already present in how we generally understand games. And Meckler et al. State that games are particularly suitable for supporting reflection as they confront players with puzzling or surprising situations which invite them to plan, experiment and look for new solutions. And this matches the 3 key stages of reflection. So there is huge potential for games as a medium to support transformative reflection. Again, using the literature, we created overall design principles, and our main emphasis in both our own design process and in the Provoking Games product that we were working on was on interpretive flexibility, disruption of or subverting of player expectations, expected failure and or frustration during the construction of meaning, explicit out-of-game reflection, and rigour. Our aim was to focus players' attention on critically examining the game object's behaviours and the rules governing their interactions to create those deeper reflections. Therefore, the majority of player responses should take place at a meta level, that is, outside of the game itself. Basically, we wanted to start arguments. Because disagreements or differences of opinion can help to create dialogue across disciplinary boundaries and would allow our cybersecurity experts and game jam participants to have better knowledge exchange across those disciplinary boundaries. Our hypothesis here is that provoking games would lead to increased understanding of both the topic and games as learning tools, and therefore produce better results for game jams as a whole. To create the provoking games, we use triadic game design, which is well established as a rigorous, serious game design method. Triadic game design breaks serious game design into three aspects: reality, meaning, and play. Reality is where the investigation of the problem area and the associated subject matter takes place. Meaning is the intervention strategy to generate change, and play is where you design the gameplay to best achieve this change. So our design was highly interdisciplinary, and this screenshot here shows how the entire project team took part in top-level matching of ideas to the project's overall topics and the overall themes during the reality phase. We then worked very closely with a cybersecurity expert and a playwright from the Civic Digits Theatre Company on the specifics of the design of each individual Small Provoking Game. And I just want to note that we consider this interdisciplinary approach to be absolutely crucial for the rigour of the process. Using some of my own previous work on serious game workflows, in the meaning phase we defined intended outcomes, the learning context, learning behaviours, and we mapped these to Bloom's taxonomy, and emotional design. We then used this information to select appropriate learning mechanics from the Learning Mechanic Game Mechanic or LMGM framework, and we also considered learning mechanics for the post-play activity, as these out-of-game reflections were core to the strategy. For the play phase, we worked with the playwright to devise a premise and a loose narrative, the plot of the game, to cover the intended outcomes arising from the reality and meaning phases. Working with the cybersecurity expert, we translated subject matter entities into game objects, and you can see these at the bottom right. And so for one example, there's a mouth, which the metaphor there is a mouth as an input device. And we also mapped the subject matter principles into game rules. So here we can see there's a spider, which is representing a malicious agent in terms of cybersecurity. Learning mechanics were mapped directly to appropriate game mechanics. We then shortlisted a set of genres and playstyles appropriate to the LMGM mappings and content that we'd created. We formulated player actions and designed the serious gameplay loops. It's important to note at this point that this was not a fully linear process. There was obviously an iterative design cycle, which helped to clarify and reinforce elements across all three of the triadic game design phases. This is the gameplay loop for the first game, which is called Protection. And in this game, the main theme was code security. The most relevant learning mechanics were simulation of a fictional yet recognizable situation, which allows players to explore and experiment in order to reverse engineer the rules of the game. That in turn allows them to analyse and plan how to succeed. We deliberately excluded instruction and guidance from our learning mechanics. However, both implicitly in the metagame while playing and explicitly in the post-play activity, the player is prompted to compare how these rules reflect or contradict their own mental model of their cybersecurity practices. To serve the learning mechanics shown here in blue, we selected core game mechanics shown here in yellow, and the core game mechanics were movement to explore and to avoid threats, collection of defences and mitigations, so power-ups in the game, design and editing to create a defence strategy for your player character, and of course strategy and planning to adapt to the changing context of the game. In the second game, which we call Collaboration, the themes were communication and resources under the main topic of the security life cycle. Learning mechanics were identical to protection, explore, experimentation, feedback, analyze. However, this time they were mapped differently. We mapped them to game levels and game turns, and these represented time in the security life cycle of a software development project. We also mapped them to action points, which represented worker time or worker resources, and the same kind of planning, design, resource management and feedback cycle that we saw in protection. So these are the two games. You can play them for yourself at the links here. Protection is a short 2D side-scrolling, real-time single-player game. And the story takes the protagonist, this little cutesy icon in the middle there, on a journey of natural evolution and intentional change. Intentional change is ensuring the survival of this character by installing combinations of different defense systems. The character has no explicit purpose other than surviving in the harsh native environment, the jungle that you see here. And the story concludes with the protagonist symbolically mastering these conditions and flying away. Collaboration, which you see a screenshot on the right here, adopts the same fictional universe with its light-hearted tone and colourful iconography as Protection, and is a turn-based puzzle game, with each level representing a workday and a whole game run representing a software project. The puzzle for each level is to find the appropriate actions to take in order to make the safest rainbow possible, where the rainbow represents the software that you're developing. The player can choose to spend their action points either constructing a rainbow lane, which represents writing code, or communicating with co-workers. And this is a direct translation of the key message that communicating is as an essential and time-consuming aspect of coding, but equally an integral part of development work. Both games are coded in Unity, and you can play them online. So do they actually work at provoking reflection? Well, a detailed evaluation of the dialogue and knowledge exchange inspired by the game is coming up as part of the final phase of the SECRIOUS project. However, at this stage, we can give you our own preliminary reflections. So both games were designed with the fundamental concept of provocation through both the subverting of player expectations and of withholding information about the game rules, which forces players to experiment, explore, and actively construct their own meanings and mental models. So the learning mechanics were the same, but the game mechanics were different. The abstraction of technical detail and focus on visualizing concepts and processes through a friendly metaphor made the provoking games, we think, an ideal medium for introducing cybersecurity to a novice audience. And the adoption of this metaphor makes the post-play activity essential to a complete experience of these provoking games. As whilst the games in isolation could create critical reflection, our overall purpose was reflection as part of a game jam. Our goal was to create dialogue as players compared and contrasted different interpretations of the metaphor, and by doing so deepen their understanding of and relationship to cybersecurity concepts. Recontextualization during the post-play activity, which you see an example of here, this actively prompted players to compare their in-game experience with their real-life practices and note any new observations arising and their potential implications in real-world terms. Post-play reflections did demonstrate a variety of interpretations, and furthermore, players effectively analysed and remapped the in-game content to our cybersecurity concept cards, the red cards here, with some very insightful responses. Therefore, we consider the ambiguity in asset design and gameplay to be successful. We deliberately avoided explicit gamification or reward structures, and also in the first game, Protection, avoided any instructions or tutorials. It could be argued that this unfamiliar gameplay encourages reflection. However, it may also have decreased engagement, and we did observe this with younger players when we ran the game jam with a teenage audience. We successfully created surprise and frustration at the points we intended to, and there is some evidence that this might have led to fruitful dialogue in the game jams. Finally, it's important to note that our small provoking games were designed as a single or very limited play experience. Replayability is not a design goal, and the focus was firmly on their place within a wider educational and creative methodology. This implies that small provoking games for similar purposes could be made even shorter to improve completion while still providing the basis for critical reflection. There are full details about all of this work in our paper. Thank you very much for listening.